Writing formulas. So we have 5 rules that we can use in order to write the chemical formulas, if we are given the names of the compounds. However, we have to identify which rule to use. Similar to the naming of compounds, we can use certain steps. First, we have to identify what the elements are. Then we have to determine whether or not we have 3 or more elements. If we do, then we need to use the table E for polyatomic ions. And then we need to classify the elements of whether or not they're metal, non-metal, transition metal, and so forth. And then we identify which rule to follow. Now, to write the formulas, we need to first identify the symbol of each element. Then we need to identify the charge for each element, and then we balance the positive and negative charges so that it zeroes themselves out. And then we write the symbol, placing the subscript after the symbol. In rule number 1, we're dealing with metal and non-metal, and we want to identify the symbols, the charges for each symbol, and then use the crossover method to identify the subscript. So let's take a look at aluminum bromide. In aluminum bromide, we have aluminum and bromine. So let's write down those symbols. Aluminum and bromine. We can see from the periodic table that aluminum has a positive 3 charge and bromine has a negative 1 charge. Remember, if it's the last element, we will use the negative number. So we will write down those charges. Positive 3, negative 1. So using the crossover method, all we have to do then is bring them over. And remember, when we bring them over, we are not bringing over the charges. We're just bringing over the number. So now, the chemical formula should be Al1Br3. Remember, we do not keep the 1. So we're going to rewrite this formula as Al3. And that is the chemical formula for aluminum bromide. In rule number 2, we're looking at metals and polyatomic ions, okay? So first we're going to identify the symbol for the metal element and the polyatomic ion using table E, identify the charges, and then we're going to use the crossover method. So in this case, the example potassium nitrate, we see the potassium is K and that nitrite is actually NO2. So we're going to write that down. So potassium is K and nitrite is NO2. Now remember, we need to get the charges. So the charges for potassium is positive 1, while the charges for nitrite is a negative 1. So we're going to write that one down. So that is a positive 1 and negative 1. So we're going to crisscross, and we crisscross, in this case, since it's 1, 1, there's nothing to do. So the chemical formula for potassium nitrite is KNO2. The third rule deals with transition metals and nonmetals. So again, we're identifying the symbols, we're identifying the charges. Note that the transition metal will have the Roman numeral that will identify the charges in the name, and we're going to use over the crossover method. So let's take a look at iron 3 fluoride. So in iron 3 fluoride, we know that iron is Fe, and we know that fluoride is F. So we're going to go ahead and write that down. So iron is Fe and fluoride is F. Now to get the charges, we are going to look at F, which is a negative 1. And to get the charge of iron, we're actually going to be looking at the compound name. And in this compound name, notice that the Roman numeral said 3. So that gives us the charge of iron. So iron will be a positive 3 charge. So now we're going to use the crisscross rule. And we see that Fe is 1 and F is 3. And remember, we don't keep this 1, so we're going to rewrite this chemical formula to be FeF3. So rule number 4, we're dealing with transition metal and polyatomic ion. We're going to identify the symbol for the transition metal and the polyatomic ion. Then we're going to identify the charge. Remember that for transition metal, the charges for the transition metal is in the compound name. And for the polyatomic ion, we need to go to table E to get the symbols and the charges. So, and then after that, we use the crossover method. So let's take a look at nickel acetate. So our symbol for nickel is Ni, and the symbol for acetate is one of these two. We can choose either one. I'm going to choose the first one. So that is C2H3O2. Okay. Now, acetate has a negative 1 charge. To make this easier on me, I'm going to put this all in parentheses. Okay. And then I'm going to write the charge. So the charge of acetate is a negative 1 charge. And for nickel, the charge is given here, which is a 2 or positive 2 charge. So I'm going to put a positive 2 charge here. Now I'm going to use the crisscross rule. I'm going to bring this down here, and I'm going to bring this on the outside. So therefore, nickel will have Ni 1, and acetate will have C2H3O2, and a 2 charge on the outside because there's 2 of acetate. Remember, we do not keep the 1, and so we're going to rewrite this as Ni C2H3O2 2. And that is the chemical formula for nickel 2 acetate. Rule number 5, deal with nonmetals, nonmetals. In this case, we're going to identify the elements, and we're going to use the prefix to indicate the subscript, and then we're going to identify the second element and use the prefix to indicate the subscript. So let's take a look at this example, dinitrogen hexafluoride. So in this case, we can see that nitrogen and fluoride are the 2 elements. So let's write that down. So nitrogen is N, and fluoride is F. Now the prefix in front of nitrogen is di, and the prefix in front of fluoride is hexa. So di is 2. So that will give us the number 2 as the subscript. And hexa is 6. So that will give us the subscript 6 after fluoride. And so the chemical formula for dinitrogen hexafluoride is N2F6.